Hey math kids, today we're going to talk about algebraic expansion and factorization. So once again, I think this will feel like mostly a review. There might be a few things in there. Okay, so the important thing here on this problem is to remember that when we're multiplying things that have the same base, so all these x's are considered the base, when we multiply them, we add the exponents. So we're just going to distribute. So we have x as our base, and we have negative 1/2 and 3/2, so that's going to be 2/2. We'll simplify later. Okay, this is going to be 2 times x to the 0, because negative 1/2 and positive 1/2. And this is going to be negative 3x to the negative 2/2. Okay, now if we go through and simplify that, this is x to the 1, or just x. 2 times x to the 0. X to the 0 is 1. 1 times 2 is 2. And then this is just going to be negative 1. So we have it that way, but remember, negative means we're on the wrong side of the fraction. So we're going to rewrite this one as negative 3 over x. That would be the end of that one. Alright, now we have 2 to the x plus 3, 2 to the x plus 1. And they want us to expand and simplify. So we're going to multiply those. And if we do that, we just add the exponents, so 2 to the 2x. We do this, plus 2 to the x, plus 3 times 2 to the x, and then plus 3. These are common terms, so they would be 4 times 2 to the x, and we just write it like that. Now we have 7 to the x plus 7 to the negative x, quantity squared. When we square something, we want to make sure that we write it as something times by itself. It's a common mistake to try to distribute the square right there. That's not the correct way to do it, so don't do it that way. Alright, if we do this, it's going to be 7 to the 2x. This is going to be 7 to the 0. This will also be 7 to the 0. And this will be 7 to the negative 2x. 7 to the 0 is just 1. 7 to the 0 is just 1. Add those together, we get 2. And we will just leave it like that. Okay. This one wants us to factorize. I'm going to write the next one down too, so we can just jump into that one. Okay, so the first step is remembering that when we add exponents, that really meant that we were multiplying before. So 2 to the n, 2 to the 3, plus 2 to the n. So if we look at both of these pieces, they have 2 to the n in common. And so we can factor it like that. This is really just 8. 8 plus 1 is 9. And so we can write it like that. We're going to approach this similar. So 2 to the n, 2 to the 3, plus 8. This time, let's think of it like that. So both pieces have an 8. Take out the 8. And that's all we can do on that one. Now we have 2 to the 3n plus 2 to the 2n. So breaking it up kind of how we did last time, 3n could be written as 2n plus n. These both have a 2n, or 2 to the 2n. And that's how we would factor that one. Alright, we still have quite a few left. So we have 4 to the x minus 9. Then we have 9 to the x plus 4, 3 to the x plus 4. Okay, both these, they want us to factorize. So what we're going to do difference of squares on this one, which is where we have something squared minus something else squared. So we have to make this look like it's something squared. So if I just change this to 2 squared raised to the x minus 9, and then since we can multiply these together, the rule for exponents is to multiply them together. We could write it like this. We could switch those places. And then this could be written as 3 squared. Once we can see what's being squared, we just write those added together, and then we multiply that by those being subtracted from each other. So that's the answer to that. This one we're going to start off kind of similar. We're going to think of this like 3 squared to the x. We're going to swap places. Okay, now I'm going to say that u is equal to 3x and replace that. And when we do that, we can see that this follows ax squared plus bx plus c. So it follows a quadratic pattern. And so we can just do t factoring. We want it to make a 4, so positive on both. U plus 2 squared, and then replace my u with 3 to the x. And so that's what it would be. Alright, now we have 6 to the n over 3 to the n, and 4 to the n over 6 to the n. So, how we're going to think about this, this can be written as this, because in this situation we would distribute the n to both pieces, and then if we just do 6 divided by 3, we get 2. So it's 2 to the n. Similar thinking here, 4/6 raised to the n. Divide that, it's 2/3 raised to the n. Yeah. Keep going. 3 to the n plus 6 to the n over 3 to the n. And we have 2 to the m plus 2 minus 2 to the m over 2 to the m. Okay. What we're going to do is we're going to break this up. So that's going to be 2 to the n, 3 to the n. And since this has a 3 to the n, this and this, we can cancel all of that. So this, and this cancel. Since this goes away though, we need to leave a placeholder of a 1. So it's going to be 1 plus 2 to the n for our final answer on that. Okay, similar thinking here, we're going to get 2 to the m, 2 to the 2, minus 2 to the m over 2 to the m. There's really a 1 out in front of here, so when we cancel all of these, we get 2 to the 2 minus 1, or 4 minus 1, or 3. Alright, we have one more to do. It's 2m to 2 raised to the m plus 3, 2 to the m over 9. What we're going to do is write 2 to the m, 2 to the 3, plus 2 to the m over 9. These both have 2 to the m in common. If we simplify this, it's 8 plus 1. So that's 2 to the m times 9 over 9. 9's cancel, so the answer is just 2 to the m. If you need additional help, please come to Math Lab. Until then, calculator.